In Math Activity 6.2, we use decimal squares to model the operations. Again, the reason we are using decimal squares is so that you will understand why an equation equals a value rather than just a procedure, and you will be able to teach your students why the operation is performed this way, rather than just focusing on a procedure. If you understand why, you'll be able to more easily apply your knowledge to other constructs. In Activity 1, we're asked to use our deck of decimal squares to illustrate each problem. I don't have a deck of a handy, but what I've done is actually draw two different decimal squares. I've got here 3/10 and here 7/10. And we need to show that these equal 1. If I take these three squares here and move them over here, I can see that 0.3 plus 0.7, 3/10 plus 7/10 equals 1. There are also other solutions that will arrive at the same problem. In Activity 1B, we're asked to use the same for hundredths. We want them to total 1. I know that 0.75 or 75 hundredths plus 25 hundredths equals 1. So we color in and we can see that there's 75 hundredths, and if we do the, oops, don't want that, draw it here, and this is the rest. It's another 25 hundredths. So 75 hundredths plus 25 hundredths equals 1. In Activity 1C, they want us to do it with thousandths. So rather than using squares, since we don't have the labels or the deck, let's go ahead and just look at the values. To equal 1, we add 5 thousandths to 995 thousandths, it'll get us to 1. In Activity 3, we're asked to use repeated addition to illustrate multiplication. We will be using a blank hundredths decimal square to complete each problem. So I've drawn here a blank 100th square, and we've got the number 5 times 0.5. So we need to color in, get my numbers right here. Should be 0.05, so we've got 5 hundredths, and we're going to color in just 5 of the squares. There's 1, and we're going to color in a second pair because we need to do 5 of these. There's 2, there's a third, here's a fourth, and a sixth, or fifth, excuse me. So we can see that 5 times 0.05 equals 5, 10, 15, 20, 25 squares that we've colored in. So it's actually 0.25 or 0.25 as I like to write it. In problem 3B, we've got 4 times 47 hundredths. And we're going to need to color in 47 squares 4 different times. So we have 47 squares here. And we've got 3 left over. We're going to have 4 rows. So 47 is going to get us to about here. So there's another 47. Got 1, 2, 3, 4, 5 left over. That should actually be 6 left over, because 47 plus 47 is 94. So let's get rid of that. So that's 6 left over, so we're going to need to encompass another 41 here. So there's 41. 41 plus the 6 is 47, so we got 1, 2, and we need 1 more. And we need to get, so this is 9, 39, plus 8 more. So we got this here, and that leaves us with 12 squares. So the answer goes in there once. So it goes 1 plus the difference, the total number of squares colored in here. And we know that there's 12 left, so 12 out of 100 gives us 88. So our answer is 1.88. In problem 3C, we have 3 times 650 thousandths. Well, we can drop the 0, and we know that's 65 hundredths. So, just like we've been doing, we need to shade in 3 sets of 65. So, that should give us 1 set. That leaves us 35 here, so we can shade in that 35. Plus, we need another 30. So we got that. And then we need another 65, and that will shade in everything but the last 5. So we'll have all this shaded in. So we can see that 3 times 0.65 equals 1.95. In problem 3D, we're given the number 10 times 0.08, and we'll need to color in 8 squares 10 times. So we can look in coloring that 8 squares. So we can see that if we color in each set of 8, we end up with the answer being 0.8 or 0.8. And that's what's neat about multiplying by 10. We can move the decimal over 1 spot and end up with 0.8. In activity 4.8, we're asked to use decimal squares and the sharing concept to illustrate each quotient. So in 4a, we've got the number of 8/10 divided by 4. We need to shade in 8 of the parts in a 1/10 decimal square, then split those 8 parts into 4. So first of all, let's draw our 1/10 decimal square, and we're going to shade in 8 of those parts. Okay, and then we're going to divide those into 4 parts. And if I divide those into 4 parts, there's the top. Here's 1 part, 2 parts, 3 parts, and 4 parts. So we can see we've only got 2 tenths in each one of those parts. So our answer is 2 tenths. In problem 4b, we're given 50 100ths, and we're asked to divide it in 10. So I've colored in a 100th decimal square so that 50 of the units are colored in. And then I'm asked to divide these into 10 pieces. So if I actually cut this in half, then I can split this up fairly easy into 10 parts. So I've got 1, 2, 3, 4, 5 on top, 6, 7, 8, 9, 10. So 10 pieces, and each one of those pieces is made up of 5 units. So our answer, we're dealing in hundreds, so it's 0.05. So 5 hundredths is our answer. Problem 4C gives us the problem of 400 thousandths divided by 5. So we could draw a decimal square with 1,000 places, but that's too big for the space we have. So I've drawn 2 versions here, one with tenths, because we know that 400 thousandths is the same as 4 tenths. Or I've drawn it with hundreds. We also know that 400 thousandths is the same as 40 hundredths. We need to split this into 5. I can't really see how to divide the 4 squares into 5 evenly, but I can divide 400 into even squares. If I take in, first of all, divide this into four pieces, dividing it by 5, well, that only gives us 4. That's not going to work. So if I undo those, and I'm going to divide these into 5. So let's group this up. If I divided them up into groups of 8, so I've got 8 here. Too far. Let's divide this into 8. There we go. There's 8. And then I can do another set of 8. And I can do a set of 8 here, and then it leaves us a set of 8 there. So I can see that I've got 5 places in each of those equals 8 hundredths. So my answer, 400 thousandths divided by 5 is 8 hundredths. And in problem 4D, we've got 60 hundredths divided by 15. I could have taken them to 6 tenths divided by 15, but that would be harder to divide. Here I need to create 15 little sets. So again, I just block it off and show that if I put it off into groups of 4, oops, went too far on that one. Groups of 4. I can create 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 sets. So that means that our answer equals 4, but we need to remember that this is in hundredths. So it's really 0.04 because we're in hundredths. It's 4 hundredths.